Hey everybody, Mark Bates here, and I want to talk to you about one of my favorite packages that's come out of the Buffalo project in the last 6 months, and that's Genny. Genny was originally written to help us better improve our generators. Buffalo uses a lot of generators, we generate a lot of code, and we needed generators that were more modular or easier to test, swap out pieces, and the like. And that's how Genny came into existence. But since having written Genny, I've realized that it's actually very useful not just for generators, but for writing tooling. So now I turn to Genny all the time and I'm writing tooling for the Buffalo project, for my own personal projects, or what have you. And today I want to give you a quick rundown of how Genny works and see how we can use it in our tooling every day to make our lives a little bit nicer. We're going to talk about generators and we're going to talk about runners. And those are the two core components of how Genny works. We're also going to fully test our generator that we're going to write. And we're going to generate files, we're going to run commands, and we're going to make HTTP requests. And like I said, it's going to be all fully tested. So with that said, let's dive right in. I have the documentation here for Genny up and running. I also have the documentation for the gen test package, and we're going to talk about that and how it can help us with our testing. And I also have Go Convey here running, and it's going to watch our project as we write our tests to make sure our tests pass or fail accordingly. And then finally, I have this very simple project here, and I call it Ringo, and it's got a go.mod file because we should all be using modules. It has a very simple main.go here, where all I'm doing right now is parsing a couple flags, a dry run flag and a verbose flag. And when we call this application with the dry run flag, it's going to run our generator without actually executing commands, making HTTP requests, or writing files. Instead, it's just going to kind of print off what's happening so we can see what would happen if we ran our generator without that flag. And then we're also going to add the verbose flag to our generator, so that if we call it with verbose, it's going to print off some nice deep debugging logs for us. So with that said, let's dive straight into building our first generator. Now, of course, a generator tool wouldn't be very useful if it didn't come with a generator to generate itself. So Genny does. Genny ships with a small binary named Genny, and it has a Genny new command. And when we run the help on Genny new, you can see it's got a couple different things. It's got a dry run, help, and a prefix. So let's run it with a prefix here. And now I like to put all my stuff under a folder in this package called Genny. So we're going to have under my application, we're going to have a folder called Genny, and then under that we're going to have whatever we're going to call this. Now we're going to call this Ringo as well. The generator we're going to create is called Ringo. And when I do that, it's going to generate a bunch of files for me. And actually, I'm going to run it real quick with the dry run flag, just so you can kind of get an idea here. So you see, if I run it with the dry run flag, it's going to switch into the directory I want it to run into, which by default is this directory here. And then it's going to create 5 different files for me. Under the Genny package is going to be a Ringo package, and then there's going to be ringo.go, ringotest.go, options.go, options_test.go, and a templates folder with an example text file in it here. So I'm going to go back to my project here, and you can see that I've got, in fact, have all of those things inside of my project here. Now, it's important to note you don't have to use this generator. I do it because it generates generators. It's all very meta when we're talking about this stuff that work kind of the way I like them to. And when I say work, as you'll see, it's really just a stub. And this is a pattern that I have found works really well for writing these generators. But it's certainly not a required pattern. Let's take a look what the options are here. Options is a struct that you can add whatever you want to it. And we also have a validate option on a pointer of that struct. What I usually do here is something like this. So let's say we're going to take a name here, and that's going to be a string. And in my options here, I'm going to say if the len of my options name equals 0, then I'm going to set it equal to something. I'm going to set it equal to star. since that is Ringo's last name. So now we just need to make this test for the options pass. By default, it's going to fail because validate isn't returning any errors in this case here. So I'm just going to delete that line, but then I am going to assert that our option equals our ops name, here we go, equals star. And if I just save that here, we're going to get an error, which makes sense. And we can just save that off like that, and that should solve it. And let's go back to Go Convey, and all of our tests are green. So now let's take a quick look at what was generated for us in the ringo.go and ringo_test.go files. You can see we now have a new constructor here, which takes our options and it returns a generator and an error. And I like this pattern a lot. It takes options, and again, I usually use a pointer so that we can modify the options and set some sensible defaults if there aren't any already. Then, like I said, return a generator or an error if there's a problem creating the generator for any reason. To create a new generator, we just call Genny.new, and that's going to return back a kind of configured generator that's ready to be added onto that we can do things with. Then we're going to validate our options just to make sure everything is cool, and if there's any sort of errors, we're going to return those back from this function. Now here, by default, what it's going to do is it's going to use Packer. And Packer is a tool that lets us find static files on our system and bundle them into our binaries. What we're going to do here actually is we're going to use Packer to add an entire set of files to our generator. And we can do this because Genny generators have support for adding packed boxes. And packed boxes are an interface that Packer also implements that basically represent a folder on disk. And when we pass one of these boxes into our generator, it's going to take all of the files that are in that folder in its nested folders, and it's going to add them to the generator to be generated later by our code. So what I want to do actually is I'm going to just get rid of this because I want to actually generate the entirety of this generator wherever we go to run it later. So I'm going to output all of the code we're writing now into the folder that we're working on later. And then down here, just separating it up a bit so you can see, we're going to take and create a new Plush context. And we're going to add some stuff onto the context, in this case just the options, and then we're going to add a new Plush transformer to our generator. And a transformer allows us to modify files based on extension, and we can modify everything from the name to the contents of the file or replace it entirely. And we're going to do both. We're actually going to write our own custom transformers here in a minute. But this transformer is going to take anything that ends in .plush and run it through the Plush templating engine and return the files. That's what that transformer is going to do for us. Okay, so now let's look at the test that was generated for us. It really starts here. We're going to call our new method, and we're going to get back a generator and error. We're going to assert that there's no error. We're then going to create a new runner, and we're going to create a runner from the GenTest package. The GenTest package here is a package to help make testing Genny a lot easier. And one of the things it has is this new runner function here, this one here, which returns a new runner for us. So a runner in Genny is what we use to actually execute our generators. So a generator by default does nothing until we actually execute it, until we run that generator. And that's what a runner does for us. So a GenTest package gives us back a runner that's configured to make testing our generators a lot easier. So we can use that runner, and on that runner we can add our generator that we just created from the new method. So with that, our runner now has our generator attached to it, and then we can run our runner. And that's going to potentially return an error. We're hoping it doesn't. off our runner, we can get results. And these results are going to tell us what was executed, what was created, what network requests were made, etc. And we can use those results to easily write our tests. So for example, we are expecting that 0 commands will be run, and we'll change this in a little bit, and that 1 file is going to be created for us. And then we can ask for the very first file that was created from the results, we're going to assert that it was equal to example.txt. Now this test is going to fail because we made some changes to it. And if we go back to go convey, if I can say it, we can see that it failed because it says it should have 1 item but has 5. And that's because we made the change over here to generate all of the files. And if I just put this back to templates, you can see it's going to pass. So I'm going to change this again, and we're going to say that instead of 1 file, it's going to create, and our tests are still going to fail. And again, not because of 5 files, but because the file we expected to be first wasn't. And you can see we expected example.txt, but we actually got options.go because that was the first file generated. So let's improve that test just a little bit here. And I'm actually going to change this here to Mark Bates, Ringo, Genny, Ringo here. It's going to be the name of our box. And then over here, I'm going to change this code. We're going to get a file from our results, but we're going to ask to find the file here. And the file we're going to look for is ringo.go. I'm going to assert that that was generated, and when we call find, it's going to return back 2 things, either a file or an error if it can't find it. So we're going to assert that there's no error, and then I'm going to assert that our file, the body of our file, which we can get by calling string on it, contains github.com Mark Bates, Ringo, Genny, Ringo, the name of the box that we added here. And if we go back to go convey, we have green tests again. Okay, so now I'm going to add another box to our app here, but this time I'm going to make it the templates. Now those would be generated, but they're going to be generated with the first box, but they're going to be generated under the folder templates. But I want whatever's in templates to be generated at the root of my application. So I'm also going to give this box a different name here. So now all the files in my templates folder will get run at the root, will get generated at the root of my application as well. And you can see this here failed, and I'm going to make sure my notifications are on so we can see those nice notifications. And it failed because, well, we're generating another file here. So let me go back and change this to 6, because that's now the new number of files we are creating. And again, if I look at go convey here, it passes. So let's make that just a little bit more interesting. Let's go into our templates folder now, and I'm going to add the Plush extension to it, and I'm going to open up example.txt plush, and I'm going to change this to ops name. So if you remember, we set our default name to star. So if I go over here now, I'm going to copy this piece of information here, and I'm going to pull out example.txt because that should be created, and I'm going to assert that it equals, let's see here, f.string hello from star, and I almost guarantee you there's a new line there at the end. So now that we have saved that, and it passed. So we now know that example.txt was generated and it contained our name into it. And I can assert that that will break if I change the name here to Richard Starkey. This is going to fail because our file doesn't contain hello from Richard Starkey. It contains hello from star. Okay, so Now I want to write a transformer. And what the transformer is going to do is it's going to take the contents of a file and uppercase the entire thing. So I'm going to call it up, this method here, and it's going to return a Genny transformer. Now Genny has a method called new transformer, and it takes an extension and a transformer function. So in this case, my extension is going to be .up, and it's going to take a function. Now this function definition takes a Genny file and returns a Genny file or an error. And I'm going to make sure we return the transformer down here. And I'm also going to call set strip ext to true. And what this is going to do is it's now going to, when this transformer is executed, it's going to remove .up from the files it works on. So when this transformer gets run, it's going to find any files that have .up as part of its extension. If it doesn't have .up, it's going to just move along. But if it does find .up, it's going to run our transformer. It's going to remove the .up extension at the very end. So now what I really want to do here is I'm just going to return a new Genny file, and we're going to do new Genny file S here, and we're going to get the name of the original file, and then I'm going to say strings to upper, and just uppercase the entire body of the file here. And I will obviously need to make sure to return the error as well. And now let's just write a very quick test for our transformer here. I'm going to create a new file, Genny new file S. Now Genny has a few different ways of creating files. New file S lets us give it a string. I'm going to say foo.go. Package foo here is going to be the contents of my file. I'm going to get my transformer here, and then I'm going to say that the transformer, is going to give me back a file and an error. And all I've got to do is call transform on it, and I'm going to give it the file I created. I'm going to assert that no error was made, and then I'm going to assert that the contents of the file are uppercase, so package foo, when I give it the string here. And our tests fail. Because we never gave it the .up extension. We only gave it the .go extension here. So we're going to change that. I'm also going to assert that the name of the file is foo.go and not foo.go.up. So if we go back now, all of our tests are passing. So we've successfully written a transformer in our application. Just because we've written one, we haven't actually used it in our app yet. So let's add that to our generator here. And to do that, all we've got to do is call the transformer function on our generator, and that's going to mount this transformer to be run later. So let's go back to our example.txt.plush, and let's add up to it. So you can see now that instead of getting lowercase hello from star, we're now getting uppercase. So let's go and change that here. Hello from star. There we go. And that should successfully pass our tests again. So now, before we leave the subject of transformers, there's one more transformer trick I want to show you. And often it is necessary to change the name of a file, or to write a file with a very particular name. So for example, when I was generating this code using the generator that comes with Genny, I obviously wanted to create ringo.go and ringo_test.go. Now I don't have those files exactly named that way in Genny, so I have to somehow figure out how to change the name of my template to be the name I want on the other side. And this is such a common thing that Genny ships with a replace transformer that we can use to replace the name of a file or a pattern inside of a file name to something else. So I'm going to change example.txt to be dash name dash. And the dashes have no real significance other than I find them very easy to kind of reason about when I'm looking at my file list here. So all I need to do now is I'm going to add another transformer, and this is the replace transformer that ships with Genny. And you can see it takes a search string and a replace string. So our search string is going to be dash name dash, and our replace string is going to be whatever the name is here, but we're going to say strings to lower, because I don't want a capitalized version of the file name. So now our tests are going to fail because example txt was not found. And that makes sense because we have changed the name of our file from example txt to lowercase star.txt. And if we refresh, our tests pass. So we have successfully changed the name of our file to be whatever we want that to be, in this case star.txt. Now, the last transformer I'm actually going to add to this app here is actually the GoGen transformer. And what that's going to do is let us pull in Go templates as well. Now, obviously, I'm using Go templates. I'm using Plush templates. You can write your own. All the GoGen template transformer is going to find anything that ends in that has .tmpl as its extension, and it's going to try to run through the Go templating system. Now we can give it whatever we want. So in this case, I'm going to give it options, and then we can give it some helpers here. And I'm not going to give it any helpers. I don't need any helpers. But I am going to add one more extension to this crazy file of ours here. So I'm going to open up this here, and now I'm going to add .ops, but just .name. And this time it passes. Okay, so just before we move on from transformers, let's just review here. We've added 2 different boxes of files to our application, all of the source code for this generator we're writing, as well as the templates folder with stuff we want to generate as well. We're running all of that through a bunch of different transformers. The first transformer looks for .plush extension and then runs those files through the plush transformer and strips .plush from it. The second is going to replace the dash name dash in any of our file names with a lowercase version of the name of our generator that we passed in this case star. Then we have the Go template transformer, and that's going to run any files that end in .tmpl through the Go templating system, passing in the options that we give it, and nil for helpers. We don't need any helpers here for the templates. And that's going to also strip off the .tmpl. And then finally, we've added this up transformer, which is going to find any files with .up as an extension. It's going to strip the .up from the file name, and it's going to uppercase the entire contents of that particular file. And of course, we have that all tested. So let's move on to running a command now, because that's a very important part of not just generators, but of writing tooling. Sometimes when we're writing generators, maybe we need to trigger another generator, another binary. We need to get some information, perhaps, or we want to run git init or some git command when we're doing our generator and setting things up. So how do we do that? Well, Genny lets us mount executables, rather exec.commands from the exec package onto our transformer. Sorry, I meant onto our generator. So let's do that. Let's run a command here. And the command I'm going to add is go version. Now this is going to run the Go version, and give me back the information. It's going to just log it out to the screen. Now this is going to fail, and it's failing because we have actually now added an executable to our we've added an executable command to our generator, and before we had 0 and now we have 1. So we need to fix our tests for that. So right here, I have that command, the length of commands is 0. But I'm not actually going to do that length check anymore. I'm going to go back to the gen test package docs, and we're going to look at this compare commands function. And what it's going to do is it takes a string slice of what we expect the commands that are run to be, and then the actual commands that were executed. So what we can do is we can say that there is no error, and we're going to say gen test compare commands. And so when we compare our commands, we need a slice of strings. What do we think is going to be run? In this case, go version. And then what do we expect so we can get the commands from our results? And I'm going to remove the 0 line because we don't need that anymore. So let's go back to go convey here. And now all of our tests pass again because we are expecting go version to run and it is being run. And let's assert that it was actually run. And to do that, we're going to need the logger. Now, the new runner from our gentest package has a nice logger associated with it that we can use to get all sorts of information here. So I am going to get that, and then I'm going to cast it to a gentest logger, like such. And then, of course, we're going to use it. So after my commands are run, I'm going to assert that the log stream out, log stream, which is a bytes buffer, contains go 1.12. It does not contain that because the command itself was never actually executed. So let's actually execute that command now. Okay, so off screen, I just created a new test here called test new go version. We get the gen test runner. We're going to get the gen test logger from it. We're going to mount our generator, run it, and then we're going to assert that the stream, the log stream, actually contains go 1.12. Now, if I were to open up go convey, this is going to fail, and it's going to fail because by default, gentest doesn't actually execute any of our commands. So we want to give it some command, we want to give it some output, some way of running this. So what we can do is on our runner, there are a series of functions that we can set up that allow us to customize our runner to do whatever we want. So in this case, I actually want to set up the exec function here. And that function takes a command, a CMD rather, and returns an error. So, knowing that, what I can say here is, I'm going to just kind of do something silly with the args here. I'm just going to join the args of the command with a space. And I'm going to say if a equals go version, then I'm going to write to the log go 1.12 like this. And now let's go back to our tests, and our tests all pass because we have declared how our runner is going to work when it receives a command, what's going to happen. In this case, the thing that's going to happen is it's going to log some output to our log. Now, by default, when we execute a command in a wet situation, it's going to go and attach standard out, standard error, and standard in to OS standard out, OS standard in, OS standard error as well. But that does not happen in tests for obvious reasons. So this is a way for us to configure that runner to do what we want. And we can also take this function, this test here, and I'm going to duplicate it real quick. And show what happens if I want to, say, trigger an error. And now what this error is going to do is I'm going to return back an error here. We're going to return funct error f. We'll say command not found. So whatever command I give it, we're going to pretend that it's not found. And so now I should get an error, and we can actually check the log again. This time we're going to say check it for command not found go. Oh, and the log, of course, the log does not contain command not found because we never wrote anything to the log. But what we do expect is to get an error here. Everything passes. Okay, so now we have created files, we've written transformers, we've executed commands, we've tested that commands have been executed, we've tested that what happens when a command errors out. Let's now turn our attention to writing some HTTP requests here. So I'm going to create a new function, and it's going to, we're going to call it, let's see, Buffalo. Why not? And it's going to return a Genny run function here. A Genny run function is an important part of the Genny ecosystem. Let's go look at the documentation for it. So what is a Genny run function? Here you go. A Genny run function is any function that takes a Genny runner and returns an error. And this is really the crux of how all of our generators work when we're using Genny. These are functions that get run at runtime and use the runner that was given to execute these methods. So when we're creating our command, for example, let's use that as an example. We added a command to our generator. What happens under the covers is you can see it actually goes and creates a new Genny run function and adds that to the generator instead. And then once that's kind of wrapped, it will call the exec function on the runner later when we actually go to execute the runner. And that's really kind of the magic behind how Genny works. It all really boils down to these run functions. And they're also incredibly useful for doing stuff at runtime, for creating custom content or looking up things at runtime that it's hard to kind of predetermine like we did already with files and transformers and commands. So, for example, we want to do an HTTP request. So let's do that now. So we can create a new HTTP request from the HTTP package, and we'll call it get. And we are going to get gobuffalo.io /en, and we don't have any reader to go with it. And of course, if there's an error creating that, we want to return it. Then we want to get the response or an error by calling on the runner request. And request takes the request like this and returns back a response and an error. And so obviously if there's an error, we want to return it. I'm also going to check if the response is nil here. We're going to return nil. And the reason I'm doing that is because in testing, by default, there is no response because we don't know what to give you here. So I'm just going to log a little no response here. If I can spell response, now I can. Then I'm going to, assuming that's all good, I'm going to defer the close of the body. Then I'm going to read the entire body here, io-util read all, response, the response body. Again, any errors, I'm going to error out. Then I'm going to actually create a new file. So I'm going to say new file, and then I'm going to use the bytes version this time, and I'm going to call this index.html, and it's going to take the bytes, and then I'm going to call file on my runner and give it that file. And what that's going to do is that's going to finally render or write out index.html with the results of my request. So now let's go and add that to our generator here, and we can just call it Buffalo like such, because it's going to return a Genny function to us. And now let's write a test for that, a test for a network request. So I've got this test Buffalo method here, and again I'm going to create a get a runner from the gentest package, and with that I can say assign one of these run functions to it with run, and I'm going to add the Buffalo runner to it, and then I'm going to assert that there was no error when I run my runner. Now, part of the problem we have here is that because there's no response, we're not going to get anything on our generated for us. And I can prove that here by saying results find, we'll say index.html, and now let me get the results from our run. Here we go. I'm going to assert that there's no error, although this will error when we actually run it. And I'm going to assert that f string contains the word buffalo at some point, like such. And again, if we go back here, I'm expecting this to fail, and it's because index.html was never generated. And to make that happen, to make our network request run, we're going to add one of those functions again. This time we're going to add the request function, which, as you can see, it's slightly off screen here. So it looks like this. It's a function that takes a request and a client and returns a response and an error. So let's write that out here. It's going to take a pointer to an HTTP request. It's also going to give me the client that was used to do it. And we need to return an HTTP response and an error. So let's create a new response from the HTTP test package. We can create a new recorder, and that will give us, I believe, result is the name of that function, and then we can return that. Okay, so now we've got a success. We've created a new response, but our test's still going to fail because it doesn't contain the words buffalo. So what we can do is we can, on our response header, we can, on our response writer here, I'm going to write a 200, and then I'm going to write a string on it. Buffalo is awesome. And now our test will pass. Look at that. So we have successfully intercepted our request and done something with it. In this case, we're going to mock out a response and return it. Now, as you can imagine, we can also mock out what it would be like to error out from this example as well. So the last thing I want to do is get my Go env information at runtime and save it to a file. So let's create another one of those Genny runners, and we'll call this one Go env here. And it's going to return a Genny run function. And we can say return our function here. Now inside of our function, I'm going to create a bytes buffer, and then I'm going to create a command. And this command is going to call Go env, like such. And then, if you remember earlier, I said by default, Genny is going to attach OS standard out, etc. to commands, but it only does that if nothing has already been mapped. So what I'm going to do instead is I'm going to map standard out and standard error to my bytes buffer. That way, I have the ability to check that information after I run my function. And to run it, I can call the exec method on our runner and pass in the command, and that's going to run the command and obviously return, potentially return an error. With that, I'm going to create one more file here. I'm going to say Genny new file, and I'm going to give it, call it -name .env.log.up, and I'm going to pass in the bytes buffer. And finally, I'm going to call file on my runner, giving it the file we just created. So this should create a new file named star.env.log, and it should be all uppercased. And if I go back to go convey, my test passed because I haven't actually added this yet here. So let's go and add that right here at the very end of what we want to do. We'll say run go env. And now when I run this, I'm going to get errors because we've now added a new command to our list of commands that we expect to be executed. So let's add that to our test here. So we also expect go env to be run. And now our tests fail because we're getting generating a new file onto our test. We expect 6, but now we've added 7 because we've created this new log. So let's go and change that as well. And again, I'm going to, this time, I'm going to copy my Go version function, and we're going to call this, instead of Go version, we're going to call it Go env. And instead of looking for Go version, I'm going to look for Go env, and I'm going to write to its standard output some data. I'm going to write foo equals bar, and then I am going to look for the file we created. So I'm going to, from the results, which I need to set up here, I'm going to look for star.env.log, because that's the file we're going to generate. So let me get the results from our execution here. I'm going to assert that no error was run, and I'm going to assert that that file contains foo equals bar. And notice the uppercase there because it had a .up extension to it. Now I can get rid of the logger up here. I don't need that either. And now let's go back and see what happens when our tests pass, because it did exactly what we expected to do. So we have created, overridden the Go env, which we're running at runtime. We're writing to its standard output. And then we're going to store all that in a file called star.env.log, and we're going to make sure we uppercase this whole thing. So at this point now, if we go back to Go convey, let's check and see what our code coverage percent is, and it's pretty high. As you can see here, really all we're missing is a few error checks. So while we could go and fill those in, I'm going to just skip those for now, because I think that's, you don't really need me to fill out a few more errors just to make 100%. Instead, I want to now turn my attention to actually running this for real as a binary. So let's now turn our attention to this main.go file. Earlier I told you I set up a couple flags, dry run and verbose. And I'm going to add those to the flag package and make sure to parse it. Now, down here in my actual application, first thing I'm going to need is a context, and I'm just going to use context.background here. And I need that because our runners need a context. Now, Genny ships with two different runners. The first being the wet runner. And now, if you remember when we talked about our gen test, we got a gen test runner. And runners are really the key to running all of our generators. And Genny ships with kind of two right out of the box that you can obviously further customize or write your own. And they are dry runner and wet runner. And a dry runner won't execute commands, won't write files, and won't make HTTP requests. Instead, it just kind of prints off what it would do in those situations. And that's basically what Gen Test Runner does, except the Gen Test Runner adds a nicer logger for testing, obviously. With the Wet Runner, all of those things happen destructively. So commands actually get written, files actually get written or deleted if that's what you're doing, HTTP requests get run, etc. So when we're creating our binary here, obviously we want to start with a wet runner. But if our dry run flag is set, let's use the dry runner as we did before. Now remember these runners here all have these functions members on them that we can use to override what happens when those things occur. And we've already seen that with the exec when we looked up when we changed what happens with Go env or Go version. We've also seen that with request as well, where we actually substituted in our own function there that was called by the runner and returned the response that we were expecting for our tests. So we have our runner here. I'm also going to say if verbose, let's change the logger on our runner, and we're going to use the Go Buffalo logger package to do that, and we're going to create a new debug level logger for our verbose logging. Down here, now we need to add our generator to this. Now there's a bunch of different ways we can add things to our generator to be run. We've seen those a little bit, and there are these with methods here. With takes a generator. With function is deprecated, and I would not recommend using it. We're going to skip groups because we're not going to talk about groups today. With new is one of my favorites, and what this does here, as you can see in this little example, it kind of works with that pattern I kind of was telling you about earlier, where it has a new function that takes some options and returns a generator and an error. We can also mount run functions directly on there as well, as we did in our tests. But in this case here, I'm going to call that with new, and I'm going to call Ringo new, and I'm going to give it some basic options. And the option I'm going to give it, instead of star, I'm going to give it the name Ringo. And if we get an error here, I'm actually going to fatal out like such. And then finally, we need to do something similar, but this time to actually run our generator. So now, obviously, I'll fatal out if there is an error. So now let's build our binary, and I'm going to use Packer to install this. And what Packer does, it's Packer install is going to wrap go install for me. And it's also going to go and find all those boxes that we set up earlier for the code and the templates that we want to generate later. And it's going to pack those static files into the resulting binary so we have them in our generator. So now I can run Ringo-verbose, and let's see what we get out here. We get out a bunch of information. You can see because of the -verbose, we see some debugging information here. We see some of the files that were generated, the network requests that were made, and the commands that were run. And if we look, we see we have all of those things here. So let's take a look at the Ringo env, for example. Here you go. You can see that is my Go env, but entirely uppercased. So I have done exactly what I thought I was going to do here. I generated all sorts of files. I ran stuff, commands. We can even run this dry. We can do a dry run on this. There we go. And that's going to just print off what it is we did. In this case, it's going to print off all the different files we want to generate, all the different requests we're going to make, and execs we're going to make, and files we're going to write, and what have you. So this is a great way of seeing what the output is before we even go and actually run anything. So that's it for now. I'm going to post all this up on GitHub for you, so you can follow along and play along with this at home. I seriously recommend you check this out. It makes writing tooling and generators so much nicer and so much easier because we have full control over. We can test every aspect of what it is we're generating, and there's a lot here I didn't actually get a chance to go into. So I highly recommend you check out the Go docs for it as well, because like I said, there's a lot here that lets us we can do groups and all sorts of fun stuff. So anyway, that's it for now, and I hope this helps. This video was brought to you by Gopher Guides. If you are an organization, conference, or user group looking for Go training, please visit gopherguides.com. For more great videos like this one, please visit gopherguides.tv.